In this project, we will re-architecture or refactor our services. And the title for this project is Modernizing with AWS, that is getting started with observability driven refactoring. In the last project, we basically deployed vProfile application stack on our local machine and also on AWS cloud. From the previous project, we already know how to host our application on our AWS account, and we used a strategy that is lift and shift strategy. This approach is used to build agility or to improve continuity. So we can add new features, we can scale, and effectively we can have very good performance for our application workload. Now, what is refactoring? As the name suggests, refactoring in its simplest form means changing application for the better. Refactoring is basically a disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. Its heart is a series of small behavior preserving transformations. Each transformation, called a refactoring, does little, but a sequence of these transformations can produce a significant restructuring. Since each refactoring is small, it's less likely to go wrong. The system is kept fully working after each refactoring, reducing the chances that a system can get seriously broken during the restructuring. Typically, the goal is to improve the performance, quality, and maintainability. Refactoring for AWS expands the benefits and enables additional ones such as better availability, scalability, and reliability. Now, why choose to refactor? We have to drive a new revenue streams and or we have to optimize the existing ones. We have to create improvements that directly impact future revenue capabilities. We have to deliver a better customer experience, enable fast time to market with new features, support a changing new business model. We have to comply with changing new regulations, and we have to easily scale both up and down to meet the planned and unplanned changes in the traffic. So about this project, we have a multi-tier web application stack. We are going to re-architect services for AWS so that it can enable us to boost the agility or to improve the business continuity. Let's take this scenario. Let's say you are working on a project where services are running on a physical machine or a virtual machine or the cloud machines, or it can be an EC2 instances, and you are dealing with various services for your application workload. It could be your databases, application servers, web servers, network services like DNS, DHCP, and many more services. To manage all this, you need multiple teams. You need a cloud computing team if you are using cloud computing platforms. You need a virtualization team if you are performing virtualization on data center. You need data center operation team. You need a monitoring team, system admin team, and few other teams will get involved in managing all the application workload. There is really much operational overhead. Your teams are struggling with uptime, regular scaling requirements, upfront capital investments, and regular operational expenditure if you are using your local data center. The process will be manual and it will be very difficult to automate if you have even virtualization. All these processes will be time consuming and very expensive. So for this, there is a solution. We can really use a cloud platform, but instead of using infrastructure as a service, we'll be mostly using platform as a service and software as a service. If you're talking about AWS, we'll not be going through regular EC2 instances, but we will be using some cloud managed service by AWS. And cloud means we can code our infrastructure, and for that we have infrastructure as a code. Platform as a service and software as a services are easy to manage, flexible, and are very elastic in nature. Scaling will be mostly taken care by the cloud vendor, and of course, it's going to be paid as you go with lots and lots of automations that we can do. Refactoring our application can give us easy infrastructure to manage, very good performance, very convenient to scale, and you will not need huge team to manage all this. In this project, instead of using regular EC2 instances to install our services, we'll be using Beanstalk service. This service will in turn create EC2 instances and host our applications on it. And we don't need to manage EC2 instances manually. Beanstalk service will take care of it. Beanstalk service will also have load balancer. It will also have auto scaling and S3 bucket for storing the artifacts, and we can use our S3 bucket. It's all about the front end. Let's talk about the backend. In the backend, we'll use the RDS instances. It's really a platform as a service. So you get a database platform to choose from, fill in the requirements, and your database is up and running in no time. Scaling will be very easy. Regular backups will be taken up automatically. So many amazing things will. We are going to use Elastic Cache instead of Memcache, ActiveMQ in place of RabbitMQ, Root 53 for DNS, and we are also going to use a CloudFront for content delivery network. So if you have a global audience using CloudFront for cloud content delivery network, it will be very easy and convenient. So let's keep the objective in mind. We need a flexible infrastructure. We need a pay-as-we-go model, no upfront costs, infrastructure as a code, platform as a service, and software as a services for ease of managing our infrastructure, so to have low operational overhead. So this is the architecture for our project. The users will access our URL, which will be resolved to our endpoint by our Amazon Root 53. The endpoint will be Amazon CloudFront content delivery network, which will cache so many things to serve the global audience. From there, the request will be redirected to application load balancer, which is the part of Elastic Beanstalk application. Beanstalk. An application load balancer will forward the request to EC2 instances, which is in the auto scaling group. Here, the Tomcat application services will be running, and all this will be a part of Elastic Beanstalk. There is also an Amazon Cloud Watch. Alarms that will be monitoring auto scaling group and will scale out and scale in based on the requirements. There will be S3 bucket where our artifacts will be stored, and we can deploy our latest artifacts by just clicking a button. So runtime content will be managed by the Beanstalk. For backend, instead of using RabbitMQ, we are using AmazonMQ. Instead of using memcached EC2 instances, we are using Elastic Cache services, and we are using, instead of using a database, we we are going to use Amazon RDS. This was about the architecture for the project. And now let us go and let us understand the flow of the execution. For the flow of the execution, you have to go through the following steps. You will log in into your AWS account, will create a key pair for Beanstalk instance login, will create a security group for Elasticache, RDS and ActiveMQ, will create RDS, Amazon Elasticache and Amazon ActiveMQ will be creating Elastic Beanstalk environment, will be upgrading the security group of backend to allow internal traffic, will be upgrading the security group of backend to allow all the traffic from the Bean security group, and we'll launch EC2 instance for DB initializing. We'll log in into the instance and initialize RDS database. Then we'll be checking the health check on Beanstalk on logging in. We'll add 443 HTTPS listener to our Elastic Load Balancer. We'll build some artifacts with backend information, deploy the artifacts to Beanstalk, and we'll be creating CDN with SSL certification. We'll update the entry in GoDaddy DNS zones, and finally we'll be testing the URL. These are the steps that will go in our flow of execution, and all these steps will be discussed separately in the different parts of this project.